Welcome to proportional and non-proportional relationships. So the TLDR on this, I'll give you the quick, easy, fast version. Proportional basically passes through the origin point. Non-proportional does not pass through the origin point. So it has a y-intercept while proportional doesn't. And while going through this, you'll see what I mean. And let's get started. All right. Linear relationships can be proportional or non-proportional. A proportional relationship means that there is a consistent ratio. Ratio. I'm going to keep it big. It's funny that way. Between the values of x and y. Complete the table below to review the distances between proportional and non-proportional relationships. So, proportional relationships. Basically, what happens if you take away the b value in y equals mx plus b? You get y equals mx. But for some reason, they change it to y equals kx. Now, it's the exact same equation, they just replace m with k, where k is the slope or the rate of change. Non-proportional, hopefully you know this one, can be written as y equals mx plus b, where m is the slope and b does not equal 0. So an example of a proportional relationship is y equals 2x. You see how there's no b value there? That means this thing will pass through the origin and it's proportional. An example of non-proportional would be y equals 2x plus 1. This thing is non-proportional because it passes through some other point than the origin. Now, for proportional relationships, all you have to do is take the value of y divided by x, and it's consistent. So any y divided by any x will give you k in this instance. So 6 over 2 is 3, 12 over 4 is 3, 18 over 6 is 3, 24 over 8 is 3. Easy. The ratio of y over x for non-proportional relationships is not consistent. This is because it does not pass through the origin point. It passes through some other point. So it's kind of like your y2 minus y1, your rise over your run, but it's just talking about the y value over the x value. Any graph that is both blank and blank contains the blank. So proportional and passes through the origin? I'm not sure what they're going for here. So any graph that is both proportional. I'm going to say proportional. Any graph that is both proportional and something contains the origin point. Yes, in huge letters, because why not? I'll tone it down just a smudge. There we go. Any graph that is not proportional or does not contain the origin. So if you look at these graphs, they do not contain the origin point, while these ones do. All right. So this says, is this the, oh, okay. This is the end of the first page. Complete each relationship for each situation described below, then determine if the situation is proportional based off the representation. So read the thing, say if it's proportional or not. Hillary is looking for a gym to join. A local gym, Forever Fit, is offering a special deal. Well, new members pay $30 per month and no sign-up fee. So the equation would be y equals $30 a month. No sign-up fee. So is this proportional? What do you think? So you better believe it's proportional. So $30, 60, 90. So it kind of looks like this. So there's your graph. There's your zoomed in version of your graph. And then for the first month, month 0, it's going to cost $0 because there's no sign up fee. We haven't used the gym yet. Month 1, because it passed through the origin point, right? It's going to cost 30. Month 2 is going to cost 60. Month 3 is going to cost 90. What a concept. Explain based on your representation. Is it proportional? So the equation, yes, it's y equals kx or y equals mx. I don't care how you say it. Just know it's proportional. No b value. The table passes through the origin. And the graph passes through the origin as well, so we know it's proportional. All right, I don't know why it keeps bugging out, but that's okay. Go ahead and fill out the rest of the notes on your own. Good luck. That was it for proportional and non-proportional. Hopefully you got the gist of it. If not, ask me in class. Thank you, and see you later, alligator.